Assalamualaikum and hi to my student. This video lecture is about the first type of the relations that we will try, which is the reflexive. Based on the definition of reflexive, it states that any given relation R is reflexive if an ordered pair which contains the same element left and right, AA, is in R for every element of A in the given set. So what it means, for this case of reflexive, we must identify first the elements that is in the set. For example, if we start as A, you have 4 distinct elements. We don't list down yet what is the ordered pairs inside, but R will be reflexive if we have this idea of ordered pairs. AA, right now we have 1, 2, 3, 4. It is reflexive if we check in the given R, it has 1, 1, 2, 2, 3, 3, and 4, 4. Because basically these are all the elements which exist in here. 4 distinct elements, 1, 2, 3, 4. It is reflexive if you have A equals to 1, 1, 1, A equals to 2, 2, 2, A equals to 3, 3, 3, and also A equals to 4, 4, 4. Okay, let's look at the previous example that we already did in our previous lecture, which is R1. Again, we start first with by defining the set. For this example, A equals to 1, 2, 3, 4, and let's start with R1. A larger than or equal to B. If you list down all the possible ordered pairs which satisfy the relation of R1, you will have 1, 1, there. But we don't answer the question yet. For example, if the question asks, is R1 reflexive? Why? We must state our reason. And when we want to justify our reason, it is best if you remember the definition, you base your argument according to the definition. As it has been established that the concept of reflexive, the definition is given like this: R is reflexive if AA is inside R. Don't forget, for all A in the given set, for all elements in the given set. Right now, is R1 reflexive? Right now we have 1, 2, 3, 4. Based on our previous discussion, it must have 1, 1, 2, 2, 3, 3, and 4, 4 in order for it to be reflexive. When you already list down all the possible R1, the ordered pairs here, then you can see that it is reflexive or not. Because it contains 1, 1, 1, 1 here, 2, 2, 3, 3, 4, 4. We already have our argument. R is reflexive. Indeed, R1. And your argument, because it is proven based on the top writing there, because 1, 1, 2, 2, 3, 3, and 4, 4 is inside R1. You don't need to mention 2-1 or 3-1 because that is not needed for you to prove that it is reflexive. We proceed to the next relation. Let's take R2. You may list down all the possible ordered pairs first. It will be 1, 2, now the question, is R2 reflexive? And again, why? Remember, based on the previous definition, our idea is that if A equals to 1, 2, 3, 4, we should have 1, 1, 2, 2, 3, 3, and also 4, 4. And based on this solution, there is no such ordered pairs. Based on our counter example argument, it is conclusively been seen that R2 is not reflexive because there does not exist 1, 1 inside R2. You can also use another counter example. You can say that 2, 2 does not exist in R2, or 3, 3, or you can use 4, 4. But because this is a false statement, it's enough to show one false statement. Some of the students might also write different reasoning like this. R2 is not reflexive because 1, 1 is not an element of R2. It's not an element of R2. Although these two statements are different, but they hold the same meaning. Don't worry if you don't know to use the symbol very well. It's okay if you can write it fully in terms of the English wording. It's just a wording. The thing is that the message should be the same. The argument, the meaning should be the same. Moving forward to R6. R6 AB, A equals to B to the power of K. K is a positive integer. You must know how to list down all the ordered pairs first. And the ordered pairs that satisfy this relation is 1, 1, 2, 2, and also 4, 2. There you have it. You already can see that R6 is definitely reflexive. Don't forget to write the reason why. You must write all. That. This concludes the lecture for reflexive. See you for the next lecture.